Thanks, Rebecca. You know, I always see people do that in these meetings, like that I have these committees that I'm on, and I'm like, how do they not know they're muted? But now I've done it myself. Okay, so we're going to go ahead and get started today. What was I just saying? Oh, okay. So the quiz opened this morning at 12 a.m., the Unit 5 quiz, and it will remain open until November the 11th, which is a week from today. Thank you to Rebecca and Taylor for letting me know that I was muted. I'm so glad you guys are here. Imagine if I was here by myself and like I was muted the entire time. Wouldn't that be awful? All right. So a couple of folks sent in questions, and then there was a discussion post last night that someone suggested that I talk or that I cover section 7.2 in a little bit more detail. So I'm going to try to cover a couple of things from section 7.2, just clarify like how you plug things in the calculator. Some people were asking, they sent questions over to my plugging stuff in the calculator, something like that today. And let's see what else. Oh, I wanted to show you that flow chart that I haven't written it down or anything. I just like have it thought up in my head for constructing a confidence interval. And I'll answer any questions that you have while we're here together. I don't have like a whole lot of stuff prepared, but you know, we'll just kind of go with the flow and see what you know, what needs to be covered. All right, so I'm going to go ahead and share my screen with you guys. Somebody is unmuted. Kaylee, you're unmuted if you don't mind muting yourself. Thanks, Kaylee. Okay. So the first thing I wanted to cover is this question. I think it's from section 7.1. This is off of the practice quiz. I think it's number 3 on the practice quiz. So it says, the mean cost of a 5-pound bag of shrimp is $50 with a standard deviation of $8. Okay, so before I get to part A, I want to go ahead and just remind you of the formulas from section 7.1, which was called sampling distributions in the central limit theorem. So that section told us that the mean of a sampling distribution of sample means is denoted with this notation, mu sub x bar. It's just given by the mean of the population, which is mu. And they also told us in that section that the standard deviation of the sampling distribution of sample means is equal to, the formula is a little bit more complicated. It's just the population standard deviation divided by the square root of n, which is the sample size. We talked a little bit about why this is set up this way. If you remember, I told you guys that this formula is set up this way because it's going to penalize you if you have a small sample size. It's going to increase your standard deviation, and it's going to reward you if you have a if you have a large sample size. So your goal is to have a small standard deviation. So it's either going to penalize you if you have a small sample or reward you if you have a large sample. All right, so let's look at part A. It says, if a sample of 56 bags of shrimp is randomly selected, what is the probability that the sample mean would be less than $49.1? Round to 4 decimal places. All right, so let's just go through and identify a couple of things here. 56, that is our sample size. Then we can use our formulas over here to find out the mean. So they told us the mean cost of a 5-pound bag of shrimp was $50. Standard deviation was $8. So notice they have this key word in here. I wanted to point that out. What is the probability that the sample mean would be less than $49.1? All right, so really I just want to highlight this part right here. So since we have that keyword in there, sample mean, that tells us that we're going to be using the formula for sampling distribution of a sample mean. So that's why I'm using these formulas over here. So the standard deviation of the sampling distribution of sample means would be the population standard deviation, which what they told us was $8, divided by the square root of our sample size, which is 56. And I'm just going to leave it like that. That way I don't have any rounding errors when I go to plug this in my calculator. All right, so now that I've gotten all my stuff down, I've got the sample size, I got the mean, I got the standard deviation. Now I can go in here and calculate this probability. All right, so I'm going to go ahead and draw my picture. We know from section 7.1 that the central limit theorem tells us that if our sample size is large enough, if you remember, the central limit theorem says the sample size has to be bigger than or equal to 30, then a normal distribution can approximate this probability. We can use the normal distribution to approximate this probability. So I'm going to draw my normal curve right here. The mean goes in the middle. Mean was $50. Then we're going to mark our number of interest, which was 49.1, so really close there. And we're looking for the probability that the sample mean is less than 49.1, so we're just going to draw our line straight up. And now I can actually use my highlighter to highlight this side. You can see that works a lot better than trying to use that like tiny marker. Okay. So we're looking for the probability that the sample mean is represented by X bar, is less than 49.1. You don't have to write out that probability statement, but I think it helps you to get more familiar with probability notation. And we know that we can use the normal CDF function to calculate a probability when it's approximated by the normal distribution. And remember, it goes, whoops, not upper limit, lower limit, upper limit, mean, standard deviation. Lower limit would be way out here, negative infinity. So it's like negative 10 to the 99. It's been so long since we've done this, it feels like. Upper limit of the shaded area would be 49.1. Our mean is right here, it's 50. Standard deviation is 8 over, let me try that again, 8 over the square root of 56. All right, I'm going to pull up my calculator. My calculator finally died last night. Not died like it's never going to work again, but the battery died, so I have to, it's charging. So this is a different one. So let's see, second vars. Remember, that's how we get to normal CDF. Let me see if I can back this up a tiny bit. We go second vars, and it's the second option right there. Lower limit is negative 10 to the 99. Also wanted to point out, some of you have been sending me some screenshots from the textbook. I'm so glad you guys are using the textbook. This textbook is really not bad. Taught out of some. This one is pretty good. They have a lot of good examples, and they have a lot of good calculator tips in there too. All right, so mean was 50. Standard deviation is 8 divided by square root of 56. All right, then I'm going to go to paste. So if you typed it in manually, that's what your screen should look like. All right, then I'm going to hit enter. And there's my probability. All right, so I kind of ran out of room a little bit. That's okay. Equals. We're rounding to 4 decimal places, so that would be 1999. Also wanted to note, I told you guys, well, if you read that discussion post that I wrote last night, I told you guys in there that I would give you some tips and some hints on the quiz. One hint that I can give you is that the quiz does go in order of the sections. So you will see the 7.1 material, and then you'll see the 7.2, and then 7.3, and then it'll go to 8.1, 8.2, and 8.3. And then the very last question is a bonus. So I think there's 13 questions and one bonus. And the bonus is like a 7-point bonus. So if you do the practice quiz and you got the bonus question right, that would be like 12 bonus points on this quiz. And that, getting bonus points on this quiz can help make up for like maybe doing poorly on a previous quiz, if that makes sense, by the way the averages are calculated. All right, let me stop rambling and we'll go on to part B. I wanted to cover this one because I do have one like this on the quiz, and I'll explain what I mean by one like this whenever I get to this part. It says, if a sample of 56 bags of shrimp is randomly selected, what's the probability that the sample mean would differ from the population mean by less than $1.2? Round your answer to 4 decimal places. So I do have one on the quiz that asks this question, what's the probability that it would differ from the population mean by less than? I wasn't intending to use that pink highlighter, but it'll be fine. So make sure that you know how to do these problems. Make sure you know what it means when it says what's the probability that either the sample mean or the sample proportion would differ from the population mean or population proportion by less than a certain amount. So make sure you know how to do those problems. And I'm going to go through it right here. So sample size is the same, mean is the same, standard deviation is the same. We just need to draw a new picture here. So we're going to draw our normal curve. I really think it's a good idea to draw the curve every time. I know it's a little bit of an inconvenience. It takes a little bit of time, but I think it does help. Okay, so it says, what's the probability? Now I've drawn the curve, I've marked my mean. Now I'm going to look for my numbers of interest. It says, what's the probability that the sample mean would differ from the population mean, which we said that was 50. So would differ from 50 by less than $1.2. Okay, so we need to go down $1.2 and then up $1.2. That says 50, not 60. So that would be, I'm not even going to try to do that in my head, 48.8. And then this one, I can do this one in my head, 51.2. I'm going to mark my two numbers of interest, 48.8, 51. Oh, do y'all see what I did here? I was like, why did I put 56 there? I put the sample size instead of the mean in the middle. That was my bad. I was looking right here at 56. So the mean goes in the middle. The mean, we scroll out a little bit, was 50. My bad. 51.2. All right, so go ahead and draw two lines at your numbers of interest. All right, so it's asking what's the probability that the sample mean would differ from 50 by less than $1.2. So that would be in this middle area here. That would be all the numbers that are less than $1.2 away from 50. Okay, so we're going to shade in the middle. Go ahead and shade in the middle. And that's the probability we're going to find. Okay, so we're looking for the probability that the sample mean is between these two numbers, so 48.8 and 51.2. Right, we know that the central limit theorem tells us that, again, we can use this normal curve to approximate our probability. So it goes lower limit, upper limit, mean, standard deviation. Lower limit here would be 48.8. Again, it's the lower limit of your shaded area. Y'all are probably experts at plugging in these normal CDF problems at this point. Upper limit is 51.2. Mean is 50. Standard deviation is 8 over square root of 56. Okay. I'm going to clear out what I already had typed in my calculator. Okay. And
Barry, you said 56, not 50 for the mean? Or is it going to be population?
The mean is 50. So if you look up here, the mean is 50. And then the standard deviation is 8 over the square root of 56. Let's see if I can back that up. Does that make sense? Did I say the wrong number? I may have said 56 on accident.
You're fine, Miss Berry. I just wanted to clarify.
Okay. All right. Let's go ahead and plug this in. So second vars, go to normal CDF. Whoops. My calculator's like bouncing all over the place because I got it propped up on this camera. All right, lower limit 48.8. Upper limit 51.2. And the nice thing about these like TI-84 plus CEs is that they save the last thing you typed in. So it's already got my mean and my standard deviation in there. So I'm going to go down to paste. Some other calculators may do that too. The only calculators I've ever used is the TI-83, and then I had a TI-84 Silver Edition, I think it is. All right, so that's what it should look like if you typed it in on your home screen. And I'm going to hit enter, and there's my probability. Much larger than our last one. That was like 19.99%. This one's like 73.83%. So 0.7383. Oh, and I was thinking about this yesterday. Last night I was just looking over all the quiz questions again. And the only one that you have to manually type in the answer for is one where I ask you to find like the minimum sample size. If you remember those problems from chapter 8, that's the only one where you have to type in the answer. The rest of them are multiple choice. So there's one where you have to type in the answer. The other 12 are multiple choice. Even the bonus is multiple choice. Okay. So that was for section 7.2. Just flipping through here with my, in my textbook. Now I'm in section 7.2. I want to go ahead and let you know. Let me draw a little line here. Section 7.2. There are no questions where you need to find, let me move my screen down. There are no questions where you need to find the standard score, also called the Z-score. Oh, I don't know what just happened. So I'm just, I'm going to put my textbook under the camera here. Let me see if I can make this bigger. I'm looking right here on page 363. This is the first page of section 7.2. There's no problems on the quiz where I ask you to find the standard score for a sample mean. You can see this formula is pretty complicated. And I just don't think it's necessary. I've asked you to find a standard score on a previous quiz, so I feel like I've already tested you over that knowledge. So I don't think it's necessary to test you over that again. I'm going to flip over, see what else we got in here. Okay, so the next question, the rest of the questions in section 7.2, let me scoot this down because this is from section 7.3. The rest of the questions that are in section 7.2 deal with the central limit theorem and doing problems just like the one we just did. I'll do another problem from this section. I'll probably have to type it out because it's kind of long. Let me make that font bigger. Okay, let's say, according to the CDC, the mean total cholesterol level for persons 20 years of age and older in the U.S. was, I'm kind of abbreviating this just to make it easier for us to write down, was 197 milligrams per deciliter. Okay. What is the probability that a randomly selected adult, sorry, I'm having to do this like in the moment. I was talking to someone in the parking lot and got distracted. We have a total cholesterol level of less than 183 milligrams per deciliter. Use a standard deviation of 35 milligrams per deciliter and assume the cholesterol levels are normally distributed. All right, then I'm going to go ahead and add in the part B. What is the probability that a randomly selected sample of 150 adults from the population will have a mean total cholesterol of less than 183 milligrams per deciliter? Okay. Again, it says use a standard deviation of 35. Now, I wanted to put this problem or a problem like this on here for a specific reason. So I'm going to go through, I'm just going to do this problem and then I'm going to tell you what part of this you can expect to see on the quiz. All right, so if you're still writing this down, I'm going to give you a minute to catch up. All right, so according to the CDC, the mean total cholesterol level for persons 20 years of age or older was 197. Okay, so the mean was 197. I want you to pay close attention to the difference in the wording in part A and part B. So we're going to read both of them. What is the probability that a randomly selected adult from a population will have a total cholesterol level of less than 183? Use a standard deviation of 35 and assume the cholesterol levels are normally distributed. Okay, so that's part A. Now, I want you to look at this question in part B. I'm going to read it in just a second, but go ahead and take a second to yourself and read it and see if you can identify the difference, because they use some of the same numbers. So they use this number 183. They use a standard deviation of 35. All right, so take a second and look at that question and see if you can identify the difference. It says, what is the probability that a randomly selected sample of 150 adults from the population will have a mean total cholesterol of less than 183? Okay, so a couple of differences between part A and part B. First of all, part B has this part here where it tells you a sample size. sample of 150 adults. And notice in the second part of the question, or the second part of that sentence, it says, what's the probability the randomly selected sample of 150 adults from the population will have a mean total cholesterol of less than 183? This one up here just says, what's the probability that a randomly selected adult will have a total cholesterol level of less than 183? So there's no mention of the word mean in there. Whenever you see this part here where it's talking about a sample, it mentions the word mean when they're asking about the probability. That's going to tell you, okay, I've got to use those special formulas for the mean and the standard deviation of a sampling distribution of sample means. This one up here, you do not have to use that formula. You would just do a normal CDF like we did back in chapter 6. But here you're going to have to do these special formulas because we're referring specifically to a sample of 150 adults. Here we're just randomly picking a person off the street. Here we're asking, okay, what if we selected a sample of 150 people? What's the probability that those 150 people, that their mean total cholesterol level would be less than 183? So it's the mean of all of those adults. Here it's just, you're just looking at the probability that some random person has a cholesterol of 183. You will not see a question like part A on the quiz. Okay, there will be no question like this on the quiz. I'm not trying to trick you on the quiz. There's nothing on there where I'm trying to trick you. Somebody sent me a chat. A asked about, very good, Taylor. A asked about the population. B asked about the sample. That's perfect. That's a perfect description, Taylor. So there will be nothing like part A on the quiz. What I've already tested you over part A. That was the unit 4 quiz. This time I'm testing you over the unit 5 material, which is the part B question. Okay. So let's do part B together. It says, what's the probability that a randomly selected sample of 150 adults, okay, so sample size is 150. I say that all the time, and every time I think of it, I think of cheese. Do y'all hear me say that sometimes? Okay, so I just did it again. That was not on purpose. I've gone off the rails over here. Someone please get me back on track. Okay, so the sample size is 150. We're looking for the probability that the sample mean will be less than 183. Let's go over here and calculate our special formulas. The mean of the sampling distribution of sample means is just equal to the population mean, and the standard deviation of the sampling distribution of sample means is equal to the population standard deviation divided by square root of n. Okay, so they told us that the mean was 197. Told us that at the very beginning. They said use a standard deviation of 35. That's going to be 35 divided by the square root of the sample size, which they told us was 150. I'm just going to leave it just like that so we don't mess up with any rounding. So you can imagine, like, if you round at the very beginning, it can just throw your answer off a little bit. So I like to leave it as exact as possible. So this is the exact version of the answer. And I was trying to darken up this fraction line, but somehow I just made it look even worse. Okay. All right, so let's go ahead and draw the picture. Here's our, oh God, that was awful. Try again. All right, there's our normal curve, or something that somewhat resembles a normal curve. Mean goes in the middle, that's 197. Mark your number of interest, 183. All right, and then we got to figure out, are we shading to the left or to the right? This time we're looking for the probability that's less than 183. So go ahead and shade to the left. That's all the numbers that are less than 183. Okay, so that's going to be normal CDF. All right, so it goes lower limit, upper limit. I'm going to run out of room. Dadgummit. I'm going to see if I can move. That seems like a lot of clicking. Well, I'll just rewrite this part. Sorry, you guys. Like, grossly unprepared today. I'm just going to write it sideways. Normal CDF goes lower limit, upper limit, mean, standard deviation. Lower limit here would be way out here at negative infinity. So it's negative 10 to the 99. Upper limit would be 183. Mean is over here is 197. Sorry if you're having to crank your neck to read this. And then standard deviation is 35 over the square root of 150. Square root of this sample size. Alrighty, let me get my calculator window adjusted here. That's perfect. All right, so we're going to clear this all out. Go second vars, normal CDF. Lower limit is negative 10 to the 99. Upper limit is 183. Mean is 197. Standard deviation is 35 divided by the square root of 150. All right, now you're going to go to paste. Then hit enter. And what a weird looking answer, right? So what this means, we've talked about this a while back, but just to remind you, what this means when you see this little E is this is your calculator telling you that you're going to have to move the decimal. The number behind it, or the number that comes after E, tells you how to move the decimal. This one's negative, so that means move the decimal to the left 7 places. So you're going to move it to the left 7 places, so that's 1, and then there'll be 6 zeros. All right, so that's 1, 2, 3, 4, 5, 6, 4, 8. All right, if we're rounding that to, I didn't put where to round it, how many decimal places to round it to. But let's see what they say. Oh, they actually don't tell you. So if you normally on all the questions on the quiz, I'll have you round to 4 decimal places. So if you were rounding this to 4 decimal places, that would be 0. Now, there are no questions on the quiz where your answer is 0 or 1. I'm not trying to trick you. I have one question on the quiz that is maybe a little bit, there's like an extra step you have to do, but I'm going to cover it today. We've already covered it. We covered it during our live session, I think, yesterday. It's also on the practice quiz. It's on the homework. And so I feel like you've seen it enough times that it's not going to trick you. There's no questions on the quiz where I'm trying to trick you. So if you get a weird answer like this, you should not get any weird answers like this on the quiz. Okay. All of your answers on the quiz should be nice numbers that can easily be rounded to, 4 decimal places or however many decimal places I ask you to. All right, so hopefully that clears up some of the confusion from section 7.2. There's 2 different types of problems here. There's this problem that's really back from chapter 6. Like I said, I've already tested you over how to compute these probabilities, so I'm not doing that again. I'm just testing you over the new material, which is part B. So don't expect to see any questions like part A on the quiz. If you can do this question from part B, then you've got 7.2 down. And again, I won't ask you to compute any standard scores on the quiz. All right, so moving on to section 7.3, I think the only question that I had come in from this section was about plugging stuff in the calculator. Some of the standard deviation here, the formula for the standard deviation is kind of long, if you guys remember. Section 7.3. This was called the central limit theorem with proportions. And these were the 2 new formulas that we got. The mean of The sampling distribution of sample proportions is just equal to the population proportion. And then the standard deviation of the sampling distribution of sample proportions, this is the one that has the complicated formula. And this is what it looks like. It's the square root of p times 1 minus p over n. And again, p is the population proportion. All these questions will have to do with some kind of percentages in the problem. You'll see a percentage. And that'll sort of be like your indicator, like, okay, this is a proportion problem. So use my formula for proportions instead of for means. This question is off of the practice quiz. This exact problem is not on the quiz, but it's similar to this in that, you know, it's some kind of problem with percentages. I actually can't remember the exact problem that's on there. There's one question about Harry Potter that I think I made up. Another proportion problem too. I can't remember what the scenario is, but I don't think I copied it from here. Let's read the problem together. It says, suppose 56% of students at a university are baseball players. If a sample of 873 students is selected, what's the probability that the sample proportion of baseball players will be greater than 55%? Round your answer to 4 decimal places. Now, I don't know if you guys remember from this section, there were some requirements that they asked you to check, or they didn't ask you to check them. They told you that you don't have to check them. You can just assume that these conditions are met. But I just want to remind you of what those conditions were. You can find them on page 373 of your textbook. But the conditions were that, or the requirements were that it had to be a simple random sample. The conditions for a binomial distribution needed to be met, which, if you remember, that was like you needed a fixed number of trials. We have that because we know the sample size. Each trial needed to be independent. So if one person's a baseball player, that does not affect whether the next person you sample is a baseball player. There's only 2 possible outcomes. You're either a baseball player or you aren't a baseball player. And then the probability of getting a success is supposed to be the same every time. And they told us that you can assume that 56% of the players are, 56% of the students are baseball players. All right, so all the conditions are met. You can assume that every time. And they tell us that the population proportion is 56%, which written as a decimal is 0.56. I'm going to go ahead and draw the picture. Well, actually, first I need to compute these 2 things, right? I can't draw my picture until I know my mean. All right, so I'm going to go ahead and compute those 2 things. All right, so the mean is just the population proportion, which is 0.56. And then the standard deviation is p times 1 minus p, so that's 0.56 times 1 minus 0.56 divided by the sample size, which was 873. Really big sample. Okay, now I can go over here. Oh, and I'm just going to leave this like this, just to avoid any rounding mistakes. I'm going to draw my picture. Again, you get to assume that this, the central limit theorem tells you that since we can assume all those requirements are met, this probability can be approximated by the normal distribution. Mean goes in the middle, so 0.56 goes in the middle. Then mark your number of interest. What's the probability that the sample proportion of baseball players will be greater than 0.55? So maybe that's just a little bit below there. All right, and this one was a greater than problem, so go ahead and shade to the right. Okay. We're still using normal CDF here. You can see this is a normal curve. So I'm just going to do the probability that the sample proportion, which is p hat, is greater than 0.55. That's going to be normal CDF. All right, so it goes lower limit, upper limit, mean, standard deviation. Lower limit is 0.55. That's the lower limit of the shaded area. Again, you read graphs just like you read sentences left to right, so this would be the lower end. Upper limit would be way out here, positive infinity, so that's 10 to the 99, just a really big positive number. The mean is 0.56, and then we got that really long standard deviation formula. I'm going to have to erase that little piece so I don't run out of room. All right, so it's I'm going to show you how I'm going to plug this in the calculator. I'll go slow. 0.56 times 1 minus 0.56 over 873. Okay. And I was playing around with this last night to see if there was an easier way to plug this in the calculator than how I normally do it. And I did find a pretty easy way to plug this in. Like this big long expression right here was what I'm referring to. Right, so go ahead and clear that out. Start over with a blank slate. Go to second vars, normal CDF. Lower limit 0.55, upper limit 10 to the 99. Mean is 0.56. Clear that out. All right, here's how I'm going to plug it in. I'm going to go slow so you can see what I'm doing. Okay, so I'm going to just type it in just as it appears here. Do the square root. So second square root. Now, what I was normally doing when we were doing this together in class is I would put an extra set of parentheses around the top, but you actually don't have to do that. So you can type it in just the way it appears right here. Sorry, wrong end of my pen. Right here in this, under this radical. So 0.56, then do open parenthesis, 1 minus 0.56, close, divided by 873. And then you can see there's a big open parentheses here at the front. So I'm just going to close it down here at the back so the calculator knows this is everything that's in the square root. All right, so 0.56, then as you can see right here, parentheses, 1 minus 0.56, close that one, divided by 873. And go to paste. Okay. Then hit enter. And there we go. 0.725, oh, my bad, 7242. So if you round to 4 decimal places, that 5 tells us to round that 1 up. So 7242. There was also for the standard score. You're not going to see a problem like that on the quiz. There's going to be no problems where you're asked to calculate the standard score on this quiz. Again, like I said, I've already tested you over that. I'm not testing you over it again. Which is nice because that formula is even more complicated, which you can find that on page 374. All right, so hopefully that helps you to see how I just plugged in that square root. A couple of people were asking me about that. I know it is kind of intimidating to plug that in to the normal CDF function. But the more you practice it, the easier it'll get. And I know I say that all the time, which is probably annoying, but it's true. All right, I'm just flipping on over to chapter 8. I wanted to start by drawing the flow chart for you guys. I'm going to just put this full screen for a second because I'm not going to need the calculator for a minute. All right, so I wanted to make a little flow chart for chapter 8. And I'm probably not going to go over a whole bunch of problems from chapter 8 because they're all so similar and we've been doing them for the past 2 weeks. So I feel like you probably have a good grasp over it. but I did want to draw this little flow chart for you today. And this flow chart is going to be a flow chart for determining which confidence interval to use. I really like flowcharts. If you're going into the nursing program, I think they like to use them over there. I remember my husband always having these little flowcharts to help him go through like the nursing process. So maybe this will be a good just reminder of how flowcharts work. All right, so the first thing that you want to ask yourself is this a confidence interval problem? Is this a confidence interval problem? Are they saying something like, are you 90% or find a 90% confidence interval for something? So there's two options there, yes or no. If no, then you don't need to go any further. Then you need to go back and do a different type of problem or a different type of approach. Okay, so if yes, then you want to ask yourself two questions. Are you dealing with a mean or a proportion? So do you see things like percentages, or do you see things like either a data set or saying something about the standard deviation? So that would refer, or that would indicate that you're dealing with a mean. So is it a mean or a proportion? If it's a proportion, there's only one option. You're going to do a one proportion z interval. I think it's just INT is the function on our TI-84 calculators. So this is the function that you'll use in your calculator. That's the end of that line. If you're doing a confidence interval for a mean, this again can go off in two directions. If you remember, this was sections 8.2 and 8.1 and 8.2. Do you know sigma, which is the population? Sigma is the population standard deviation. Do you know sigma, or we'll say, is sigma unknown? Okay. If you know sigma, then you're going to do a z interval. So if you know the population standard deviation, you're going to do a z interval. If you do not know the population standard deviation, you're going to do a t interval. And again, the letters there refer to which distribution that you're using. Like z interval would be the normal distribution. T interval would be the student's t distribution. I think I'm going to redraw this little box and put it off to the side a little bit more. So if you know sigma, you're going to do a z interval. Okay, so hopefully this little flow chart will help you distinguish between which is which. I'm trying to make these different colors that are not like making it hard to read, to show you that that's where the line ends. All right, so there's our little flow chart. I thought this up when I was driving to work yesterday. So a flow chart for determining which confidence interval to use. So first question you ask yourself, am I doing a confidence interval here? If not, you know, you have to use a different approach. Maybe you're doing like a normal CDF problem. Maybe you're computing the minimum sample size. If yes, then you have to ask yourself two questions. Is it for a mean or for a proportion? If it's for a proportion, if you're seeing things like percentages, then you're going to do a 1 proportion Z interval. And again, if you have a TI-84, the way that you get to all of these options is you go to Stat and then over to Tests. All right, so for every one of those options, that's how you get to them. You go to Stat and then over to Tests. Okay, so if you're doing a confidence interval and your question deals with a proportion, you know that you're going to be doing a 1 proportion Z interval. If you're dealing with a mean, then you have to break that down even further. Do I know the population standard deviation, or is the population standard deviation unknown? If you do know the population standard deviation, then you're going to do a Z interval. If you do not know the population standard deviation, if it says either the problems that are going to be in this section are going to be either you're given a little data set. If you remember, I think we had one about like, it was a pre-test and post-test, and it was like how much their score increased by. We had a little tiny data set, and we had to plug that in our list. So either if you do not know sigma, that's going to be one type of problem that you might see in there, either a little data set, or it's going to say something about the sample standard deviation instead of the population standard deviation. So if you do not know the population standard deviation, then you're going to do a T interval. We spent a lot of time in section 8.2 learning about the student's T distribution. We spent 2 whole days talking about the student's T distribution and how it's different from the normal distribution. Remember, the student's T distribution is completely determined by its degrees of freedom. And we know that the degrees of freedom is the sample size minus 1. And whereas the normal distribution is completely defined by its mean and standard deviation. There's one more thing I want to mention, and then I'm going to end there for today because we're almost at 1 o'clock anyway. The last thing I wanted to mention is, I'm just going to, I think I'll type it out just so it doesn't look so sloppy. All right, pay close attention to what I'm about to tell you, because there's going to be 2 problems like this on the quiz, and I do not want you to get them wrong because of a very simple mistake. If you are asked to compute the minimum sample size, make sure you read the directions on how to write your answer. You will be asked to round your answer up to the next integer. Okay, so we just did one of these problems yesterday, so I know y'all remember it if you've seen that video from yesterday. This is the problems where you have to use that little formula. Let me pull this formula sheet up. I know y'all are probably writing that down. I'll come right back to it. I'm scrolling down to the Unit 5 formulas. So right here, minimum sample size for estimated population mean. So you have that critical Z value times sigma over the, what is that called? The, shoot, I'm like drawing a blank right now. It's on the tip of my tongue. It's the margin of error. There it is. Divided by the margin of error all squared. So if you have a problem where you need to use this formula, make sure you round the answer up, right? So even say you get a question, you're computing the minimum sample size and you type it in your calculator and it says something like this, 631.2. It does not matter what your rounding rule says. The question tells you to round your answer up. So round that answer up to 632. Okay. And that may or may not be the exact answer for one of the problems on the quiz. So make sure you read the directions. I know it's so easy to get caught up when you're on the quiz and you're just kind of like in the zone. You're rounding stuff to 4 decimal places. You're used to using those rounding rules, but make sure you're reading the directions. And if it says round your answer up, you know in your head, think to yourself, okay, I'm ignoring my rounding rules here. No matter what that decimal tells me to do, I'm going to round that answer up, because that's representing 2/10 of a person. I cannot poll or survey 2/10 of a person. I have to round that up and include that next person, if that makes sense. Okay, I'm going to switch over to the camera now. Whew, I was like really passionate about that last problem. I feel like hopefully no one will mess up on that, because I know it's so annoying when you get that one wrong, because you forget because you're in the moment and you're like using your rounding rules, and normally you wouldn't round that number up. Okay, so let me see if I have any other tips for the quiz that I can think of. Oh, I posted this announcement last night. I don't know if you guys saw it, but I did resolve the issue where the formula sheet was not popping up. So now the formula sheet should pop up whenever you click on it during the quiz. But of course, it's a good idea to have it printed out. So if you do have a printer, you may want to go ahead and print it out. But it should work. I tested it like 3 different times yesterday, and it worked every time. So hopefully there are no issues with that this time. I think the issue was the name of the file. I had it named something that was similar to something that was already in my course files. But anyway, I'm pretty sure that issue has been resolved now. And when I say pretty sure, I'm like 99.9% sure. Let me think. Like I said, there's the only problem I wanted to mention to y'all. I'm going to flip my screen back over real quick and just show you that one problem that I was telling you about. That is, it's not tricky, but there is a little extra step you have to do. Let's see. So make sure you know how to do these, where you're given a little data set. Right here, this last question on the practice quiz. If you remember this one from yesterday in our live session, it's where they're talking about the people that don't check their email. A survey of 111 randomly selected students in one college showed that only 85 check their email account on a regular basis. Construct a 95% confidence interval for the percentage of students who do not check their email on a regular basis. So if 85 do check their email, then that would be 111 minus 85, which would be 26 people do not regularly check their email. So you would use 26 would be your number of successes instead of 85. So make sure you know how to do that problem. That's the only problem that I would consider like sort of tricky, because it's asking you for, they give you one number, but they're asking you for another number. But the rest of them, I would not consider them tricky at all. Like I said, there's going to be no questions on the quiz where you get a weird number like we saw today with that E. You're not going to have any like that. There's none of them where the answer is 1. There's none where the answer is 0. I'm not trying to trick you. I'm just trying to check and see that you know how to compute these answers or compute these probabilities. Like I said, there are 13 questions and there is 1 bonus. Definitely try the bonus, like even if you have no clue, because it's multiple choice. So there's a chance that you could just guess correctly. And don't forget to submit the practice quiz to the Dropbox. Remember last time some people were having some issues finding the Dropbox. If you are having an issue, you're not able to find the Dropbox, it's not showing up on your end, just let me know and I'll see if I can adjust some settings and get it to show up. But I'm going to end there for today. Thank you everybody for coming today, and I wish you the best of luck on the quiz. I really feel confident that you guys are going to be able to do a great job on the quiz. If you do the practice quiz and you feel good, you're going to be fine on the quiz. It's very similar to the practice quiz. You're welcome, Rebecca. So I hope you guys have a great rest of your week, and I'll see you on Monday. And we'll be starting chapter 10, which is our last chapter of the semester, which is crazy. But anyway, I'll see you guys on Monday. Bye.